Let's go ahead and start chapter 8 now. We move into integers. This is our last chapter of the course. Integers is the introduction to negative numbers, and officially, integer is a negative, positive number, or zero. Each of those um, make up the number system of integers, right? So we're going to have some important questions in this chapter. We're not just going to go through the mechanics or the skills of how to. Remember, we want to think deeply about what integers are, how they impact young children's learning, what role they play in future mathematics, especially as they lay the groundwork for algebraic reasoning and solving equations as students move on to middle school. So hopefully we can do well and think about, how this applies to your future work as a teacher. And so we start 8.1 with addition and subtraction. And recall again, there are many real world situations where we will call on the use of negative numbers. We may have to think about it, but again, there's some classic situations. The idea of representing debt or that you owe somebody, right? A money situation, temperatures, elevations below sea level, um, thinking about the stock market up and down. So there are some ideas that you may understand, but still young children will have some basic understanding of that. So when we think about it, I would like you to start to think about what are some situations where you would actually come up with or do math in these situations, right? This is what we would talk about in class: negative 20 plus 8, negative 20 minus a positive 8, negative 20 subtract a negative 8, right? So if we were in class, we'd have time to discuss it. I came up with some situations here. If you don't want to peek yet, think about it and then come over here. Take a look at the different word problems that are represented for each of these unique situations. It's important to think about, right? About hiking up, or they went down 20 feet and then climbed up 8, right? Where's your new elevation? Submarine is 20 meters below already, and then they go another 8 meters deep, right? So you have another depth. So we're increasing our depth. You're taking away the positive eights, you're going down. And then this one's always kind of tough. We're taking away a negative. Maria owes $20 in account, and then the school removes $8 from the debt. So you could see now she owes less. So the negative, again, is a representation of some value location. So just keep that in mind again, what a negative number is. Another way to think about negative numbers is with the term opposite or the idea of opposite. So on a number line, we could see here's 5 and negative 5. They're equal distant, the same distance from 0. They're on the opposite sides. So that's another way we're going to think about positive and negative numbers, that negative 2 and 2 are opposites. Very important way to think about it. That helps it kind of later on as we do some more mathematical computations and then move to algebra, thinking about negatives as being an opposite of a positive number, right? So we're talking again about the collection of numbers called integers. So let's go ahead. Here are the integers here: negative 7, dot, 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 mean go on. Positive 7, go on. So you can see there the whole numbers, the positive, negative set of whole numbers, including 0. Now, when we think about ordering integers, we can see a number line helps us order integers. So it's important that, and often confused, that negative 2 is smaller than 1. So you could see negative 2 is smaller than 1 on the number line, right? Negative 2 is to the left of positive 1. And then we could see negative 3 is smaller than 0. It's kind of, you can see it again from the left. I think you could also see, it would be nice to point out that um, negative 3 here is smaller than negative 2. That's a common misunderstanding as we think about it. And then thinking about the rules of ordering numbers on a number line. Again, looking at this here, here's 2 numbers. And then we could say, like in this case, as we were talking about up here, use that notation. Negative 3 is smaller than 1. Negative 2 is bigger than negative 3 because it's to the right of it. And we use that less than, larger than, or greater than notation. But again, that number line helps us see which numbers are bigger. which leads us to example 1. You can see negative 3 is smaller than 5 or less than 5. This inequality here, negative 2 is bigger than negative 4. That's a common thing. Even though negative 4, I owe more or I'm further down, technically we say negative 2 is bigger than negative 4. And then getting to this idea of opposites, we can see here negative of a negative, right? The opposite of the opposite of A is A. That makes sense, right? And that's what we have here. The opposite of the negative A is positive A. For example, the opposite of negative 13 is 13. So it's another way to think about a negative, and later even when we think about like a negative times a negative being a positive. Something to think about. How about something like this before we finish this video here? The opposite of negative 2. What would that be? Well, the opposite of negative 2 is 2. And so now you have the opposite of 2. So in this case, you get negative 2. And so that's where it is. So thinking about that opposite is an important way to conceptualize negative numbers.